Okay, so um, we're going to review some of these rules, okay, for parallelograms. And it says, recall the 5 ways to prove a quadrilateral is a parallelogram from topic 6. You can find these in your notes on page 148. The other thing is obviously in your foldables. So if a quadrilateral has opposite sides parallel, opposite sides congruent, opposite angles congruent, one pair of sides both parallel and congruent, or diagonals bisect each other, it is then a parallelogram. I'll give you a minute to write this down. Show of hands who is still writing this down. Okay, so when is it a parallelogram? So if we take a look, we're going to look at these, okay? I'm not going to go through these because we've done these rules before, and I'm just hoping that you will be able to identify. So the first one, yes, the opposite angles are congruent, so therefore it is a parallelogram. Yes, the diagonals bisect each other. Here you see 3 and 3, and then you have the 2 tick marks, so that is a parallelogram. Here again, opposite angles are congruent, so it has to be a parallelogram. This one is just telling you opposite sides are congruent. It's not telling you any additional information, so that's a no. Number 5, we have a pair of opposite sides and that are congruent and parallel, so therefore it is a parallelogram. And this one is no because it has 2 opposite sides congruent, and then only one diagonal is bisected, not both. Okay. Sorry, there's a lot of writing today, guys, but you know. All right. Anybody still writing this down? All right. So now we will apply these to the coordinate plane. Which reason from above will not work on the coordinate plane? In this case, opposite angles are congruent. There's no way on the coordinate plane without using a protractor that you're going to be able to prove if they're congruent or not. Okay. So what we're going to do is we're going to kind of eliminate that option. Okay. So you're going to have a total of 4 ways that you can actually, I know it says 5, but just put 4. To prove a quadrilateral is a parallelogram on the coordinate plane. Bless you. First, to show both pairs of opposite sides are parallel by, use slopes to show opposite sides have the same slope. To show both pairs of opposite sides are congruent, You can use the distance formula, you can use the Pythagorean theorem to show that the opposite sides are the same measure. Showing one pair of sides is both parallel and congruent by using slope and the distance or the distance formula. You can use Pythagorean theorem. That's why the distance and Pythagorean theorem are kind of slashed. It depends on what you have. To show one pair of opposite sides have the same slope and measure. And then 4, show diagonals bisect each other. Using midpoint formulas to show diagonals have the same midpoint. Show of hands who's still writing. Okay. Okay. Anybody still writing? Okay. So the next thing I want you guys to kind of write down is this part. Nothing much here. You're good. You have most of them. Just remember that you could also count for the slope formula using rise over run. Okay, so just add that to your notes real quick, and then we'll move on to the graphing. So far, are there any questions? Is all this kind of ringing a bell a little bit? Okay. There it is. Okay, so let's take a look at this example 1. So we have PNHS. I'm just going to graph this real quick. So we have 3, 3, P. We have N, 8 up 2. H is 6, -1. And S, 1, 1, 0. Okay. Okay, so to show that the parallelogram, show that P and HS is a parallelogram using both pairs of opposite sides are parallel. Okay, so here's what we're going to do. We are taking these 4 things that you just wrote down, and we're going to prove that this is a parallelogram. In the end, though, you choose how you want to prove it, okay? But we're going to show you all 4 ways, and then you guys make the call. I'm not going to lie to you. Personally, I like just proving pair of opposite sides parallel and congruent, because in this way I'm only focusing on just that's all I'm focusing on. Do you know what I mean? This way you're not like solving for like 4 different slopes or 4 different distances, things like that. Okay? But let's move on to this. So this one, opposite sides are parallel. So that means we need the same slope, right? So I'm going to first focus in on the slope of PS and the slope of NH. Okay, so remember PS is 3, 1, and 3, 0. We had 3 and 0, so we're going to start with the difference of the y's. 3 minus 0 over 3 minus 1. Hi. Oh, thank you. I was going to pick that up a second. I had some time. Thanks. Good for me. Okay. Thank you very much. Okay. All set. Thank you. All set, Holly? Thank you. Okay, so this leaves me with 3 over 2, and then I'm going to do this again for NH. So for NH, I have, let's see, it looks like 2 minus a -1 over, not, okay, over, looks like 8 minus 6, which again leaves me with 3 over 2. Oh my gosh. Things are not. Okay, so that is telling me that this is parallel with this. So now what I want you guys to do is I want you to find the slope of PN and the slope of SH. Okay, I'm gonna give you guys a moment to calculate that. Anybody have the slopes yet? Anu? I'm sorry, what'd you get? Gotta flip-flop it. Yeah, so it's -1/5. Very good. So remember, the y's go on top, okay? So this will be -1 over 5. And this is -1 over 5. So those are parallel. So we just showed that this is a parallelogram. Questions on that? All right, let's take a look at letter C. So now it says show that P and HS is a parallelogram by using both pairs of opposite sides are congruent. So just like yesterday, remember when we did the triangles and we kind of left it in radical form? Same thing here, okay? So this is going to be that I'm going to start with the measure of PS, and I'm going to start with the measure of NH. So this is where the distance formula comes in. So I am going to use, again, those points, 1 minus 3 squared plus 0 minus 3 squared. And this one's going to be 6 minus 8 squared plus negative 1 minus 2 squared. In the end, both should be what? Square root of what? Anybody? Go ahead. Square root of 13. Very good. Okay, so now I want you guys to find, so we definitely know that this is congruent with this. So now I want you guys to find, in this case, the distance of PN and N8, or SH, sorry. Shouldn't have these M's there. Those aren't slopes. Who's got it? Square root of what? Anna? What'd you get? Very good. Square root of 26. Uh-oh. Okay, so that means this is congruent with this. Any questions? Okay, so we just used two of the ways. Let's look at the third way. Show that PNHS is a parallelogram using one pair of sides as both parallel and congruent. So we solved for a lot of this already. So all we need to do is kind of write it down. So in this case, if I looked at I can solve using the slope of PS and the slope of NH, which we found as 3 over 2 and 3 over 2. And we also solved that PS is equal to the square root of 13, along with NH being the square root of 13. So that's one way, okay? And honestly, I'm not going to lie to you, this is just my preference. It doesn't have to be your preference, but I'm the type of person that just likes to work with two of the lines and kind of ignore the rest if I can, okay? And then just finish everything out. Or you can do this with the other two sides. So you can do it with the measure of PN, or not the measure, I'm sorry, the slope of PN and the slope of SH, which was negative 1/5. Okay, which makes that the parallel part. And then you can do the distance of PN, which is square root of 26, and the distance of SH, which was the square root of 26. Okay? So that proves that these are parallel as well. Or that's a parallelogram. Any questions on this one? Because I know there wasn't a lot of calculation because we already did it, but I want to make sure we're okay. All right, E. Last one. Show that PNHS is a parallelogram by using diagonals bisect each other. All right, so here is our nice little parallelogram. They want us to show that this point, I'm going to do it in yellow. That point right there is the same for both. Same, they bisect each other, you know it's a parallelogram. It applies the rule, okay? So let's take a peekaroo. I'm going to apply here the midpoint. You're going to need the midpoint formula for this. All right, it's already listed at the top, so I'm not going to list it again. But if we apply the midpoint, if we do the midpoint of PH, okay, so I'm going to cross now because it's a diagonal. That's going to be 3 plus 6 over 2, 3 plus negative 1 over 2. Now this simplifies to 9 over 2, comma 1. So there's our first midpoint. And we're going to have to do this for the second diagonal also. So the midpoint, this case of SN, is going to be 8 plus 1 over 2, and then 2 plus 0 over 2, which again gives us 9 over 2, comma 1. Since these match, it is in fact a parallelogram. All right, any questions on this? Now this was just showing the 4 different ways you could do it. Okay? For the you try it, choose one of them that you think you're gonna get every time without a doubt. Okay, you can choose any method from above. B, C, D, or E. But make sure you graph it. And make sure you have your congruency statements or anything that the parallel statements, you name it, okay? I'm gonna give you guys a moment to do that. If you finish early, work on your homework, okay? You have that half sheet. You just circle it and put an arrow that way, and then you know what I mean. Yeah. All right, show of hands. Who is done with the You Try It? All right. I'm going to show you what I have, but again, remember, there are multiple ways of doing it. So I just did it with the diagonals, which was fine. Okay? The diagonals bisect each other because I got the same midpoint. Anybody do it a different way? Shane, what'd you do?
I did the congruent parallel sides.
So congruent parallel sides. Which sides did you choose?
I chose the side GE and MO.
Okay, GE and MO, and did it work?
Yes.
Okay, cool. So anybody doing a different one? So we got two. What'd you do? You did a distance formula for all four? Awesome. What'd you get? Okay, so square root of 13 for MG and OE.
Mm-hmm.
Okay, and what was the other one?
And then, oh wait, no, I didn't do it for all four sides.
You just those two. Did you do the?
And then I did slope also.
Okay, so you just did it for the opposite ones that Shane did then. Okay, totally fine. Anybody else? Again, remember, it's a parallelogram. Pick a rule, stick with it. It makes your life a lot easier. Okay, but again, I gotta show everything, right? Questions, comments, concerns? Snide remarks? No? Okay, that's it. Work on your homework. Those who watch at home, have a great day.